So in section 2.3, we're going to go over properties of trigonometric functions, including the periodic properties, and we're also going to develop the Pythagorean theorem for our trigonometric functions. Let's start with problem number 12, which is going to go, for a little while, it's going to go beyond what we're accustomed to from our unit circle. Problem 12 asks you to calculate the cosine of 420 degrees. Now, what on earth is that? How are you going to find a 420 degree angle? Yeah. So what's happening with 420 is that 420 is all the way around and then another 60 degrees. You're going to be at the same point either way, right? If you're looking at a 420 degree angle or a 360 degree or a 60 degree angle, it's still going to put you right here, and the x-coordinate is still going to be the same. So for our money, in all intents and purposes, this is the same as a cosine of 60 degrees. What's the x-coordinate at 60 degrees? 1/2. And that's it. Now, I could go another 360 degrees. I could look at the cosine of, say, 780, and it'd still be the same, right? So every time you add another lap around the unit circle, you're still getting back to the same point. And what that's saying is that cosine, and for that matter sine, have a little periodic function or periodicity. So cosine of theta is going to be the same as the cosine of theta plus multiples of 360 degrees. As you can take and add, k, which is going to be an integer. K equals 0, 1, 2, 3, etc. Or -1, -2, -3, etc. But as long as you're adding multiples of 360 degrees to your angle here, you're going to get the same value for sine or cosine. So this also works for sine as well. Sine of theta is the sine of theta plus 360 degrees times k. So what's that saying is that this function, both of these functions are periodic. Their values are going to repeat every so often, every 360 degrees. Now that's in degrees. What would this look like in radians? So in radians, what's once around the unit circle? How much? 2 pi. So cosine of theta plus 2 pi times k, or sine of theta. Sine of theta plus, again, multiples of one trip around the unit circle. So these are the periodic properties of the sine and cosine. But you can use those when you evaluate things. You don't have to evaluate the sine and cosine of these big numbers. You can pare it down. Look at something that's between 0 and 360, not something that's outside that range. Let's take a look at problem number 16. Secant of theta, or excuse me, secant of 540 degrees. Well, again, you're outside of that range of 0 to 360. So the first thing that I'll do is kind of bring that down to earth. Let's subtract off 360. So that's going to be the secant of 540 minus 360 is 180. Oh, that's better. At least it puts us on the unit circle in a familiar place. Secant is a reciprocal of what function or what coordinate? Secant is 1 over the cosine. It's 1 over the x-coordinate, or it's 1 over the cosine. What's the x-coordinate at 180? -1. So 1 over -1. So we're going to get a ratio of -1. Let's try a couple more here. And I don't know, maybe do you want to do one more with degrees? Let's maybe take a look and see if there's another one with degrees we can do. Let's try problem number 14. Sine of 390 degrees. See what you can come up with for that one. Find out in a second. Equivalently, what's this equal to? Good. Sine of 30 degrees. Sine is which coordinate on the unit circle, x or y? The y coordinate. Good. And the y coordinate at 30 degrees is 1/2. So, yes. Good job. Sine here is 1/2. We're going to do the same thing with a few of these examples using radians that we're going to do with degrees. The problem is radians is going to be more of a pain to deal with. And we'll see that right away with our first example, problem number 20. Sine of 9 pi over 4. Now with these first three examples, what would we do? We tried to bring our angle back to the range of 0 to 360, or in this case we want to do the same, bring this back to the range of 0 to 2 pi. I'm going to give you three different ways to do this. It doesn't matter to me what way you choose, but you want to bring this angle back into the range of 0 to 2 pi. So the first way to do it is this. 9 pi over 4. I'm going to subtract off 2 pi. And when I do that, I look, I'm like, well, I need common denominators. So it'll be 9 pi over 4 minus something else over 4. What would this be? 8 pi over 4. And when I do that, I get pi over 4. So that's one way. And maybe it's a little bit too brute force for you. It's up to you. Let's look at a different way. Let's just look at this ratio here. 9 over 4 is 2.25. So that's 2.25 pi minus 2 pi. Well, it's just going to leave you with 0.25 pi. It's a nice fraction. And your calculator can turn 0.25, or maybe you're familiar with 0.25, as 1/4. Or again, pi over 4. So you can work it with decimals sometimes. And if push comes to shove, you're like, you know what, I just don't like either of those. Here's one other thought. Pi over 4. We're going to convert it first to degrees, and then we're going to convert it back to radians. So to convert this to degrees, what would I have to multiply by? Yeah. Good. 180 over pi. So I'm going to get some cancellation. We've seen that before. These cancel. 4 goes into 180 45 times. So that's going to be 9 times 45 degrees. So it's going to be what? 405 degrees. Now that it's in degrees, let's take care of it here. Let's subtract off the 360. We get 45 degrees. And then turn that back into radians. So pi over 180 ends up with pi over 4. There's no really nice way that works easy all the time. It's just up to you to kind of pick a favorite. One way or another, you have to be able to convert these down to an angle that's between 0 and 2 pi. But once you're there, that puts you on the unit circle. You've got your reference angle. You should know these from this unit circle. What's the sine of pi over 4 going to equal? Yeah, root 2 over 2. 1 over root 2 is fine. It's just not rationalized. So root 2 over 2. Which one of these is most comfortable for you? 1, 2, or 3? 3? 3? 1, 3. All right. You guys are like the electorate. You're really divided in your opinions. All right, but that's cool. Anything that works. Yes? Well, you're going to think of this as 2 pi over 1, and then to get a common denominator, if the common denominator between 4 and 1 is 4, I'll multiply the denominator by 4 and then the numerator by 4. So that's how you're getting a common denominator for that first one. So effectively you're multiplying by 1. Okay. Let's do another one kind of like that. It's problem number 26. Is there anything else on problem number 20? I know this one got a little bit longer because, you know, it's tougher to work with radians. For better or for worse, radians is what they use in calculus pretty much exclusively. So it is something to get familiar with. Problem 26. Secant of 25 pi over 6. All right, so sorry about the funky 5. It's 25 pi over 6. So we have to work with that 25 pi somehow. 25 pi over 6. I want to convert that. I need to convert that to something that's between 0 and 2 pi. Let's look at it this way. 25 divided by 6 is 4 1/6. Equivalently, that's 4 1/6 pi. I haven't made any changes yet. I want to play with this until I get this between 0 and 2 pi. So let's subtract off 2 pi. What's left if I subtract off 0 or subtract off 2 pi? 2 1/6 pi. Good. It's still more than 2 pi. It's not in the range of 0 to 2 pi, not in the range of like 0 to 360. So, all right, keep going. I'll subtract off 2 pi yet again. Yeah, 1/6 pi. This is between 0 and 2. So that's a place we can stop. Yes?
I mean, it's on the page, but the way I thought about it is like 25 pi over 6. The closest one that bring it back to be something normal is 24 over 6, which is 4
pi.
Which is 2 pi, which is
You know, it's up to the individual. You know, if you can see that, gee, we'll subtract off the 4 pi right away, that's great. All right? I don't know how many people are going to, you know, subtract out the 4 pi right away or not. So this is a little bit more plotting, but it gets us there. To show you one other way, let's see. Let's convert it to degrees. I think I saw a lot of people liking it in degrees. 25 over 6 multiplied by 180 over pi. All right, so this cancels in here 30 times. And then pi cancels, so 25 times 30 is 750 degrees. And again, it's up to you. You can subtract off 360. Some of you might see that you can subtract off 720. You know, it's up to the individual. You subtract off 360, and okay, you get 390. And then, all right, well, I'll subtract off 360 again, and you get back to 30 degrees, which is your pi over 6. One way or another, you got to get back down to that reference angle, pi over 6. Secant of pi over 6. finish it up from there. Figure out what the secant is going to be at pi over 6. It's a reciprocal of one of the functions. Find the right angle, find the right coordinate, finish it up from there. If you get that one, then try cotangent of 17 pi over 4. Work with that one. That's problem number 24. While we're walking around, let me put this up here. If you want to take yours out from last time, that's fine. What I'll do for the first test, and maybe even all the tests, is give you a blank copy that you can fill in as needed.
I'll get you one, but I don't have it now. Thirds.
And then 135 is 3/4.
Makes sense to me.
Makes sense to you?
Yeah, trigonometry.
So you can be able to draw the roots without it. Just can't go. Have to go with this. Watch how you can draw the roots. That's
alright.
That's all you need. You can't go. Yeah, you have to watch it.
Finishing up 26.
Bye.
I'm getting the idea of it.
Okay.
Is that right?
More
Okay.
than just it.
Okay.
Alright, so try number 24 then. Okay, good job. Okay, yeah, there's nothing wrong with doing it that way. Glad you found a way that works for you. Okay, yeah, you just need to calculate the cotangent of that, because this and this are equivalent angles.
Okay.
Just calculate
This
the
is
cotangent.
secant minus 6.
Okay, so I left you guys off here. Secant is 1 over the cosine. So cosine of pi over 6 is square root of 3 over 2. When you invert and multiply, you're going to get 2 over the square root of 3. And then you rationalize that. We'll end up with 2 square roots of 3 over 3. And I skipped a step here in showing you the rationalization, but I think we're okay here. The tough part here is to make sure that you get this reference angle, and then you calculate it as 1 over their cosine as opposed to 1 over something else. Let's try problem number 24, unless there's some comments on 26. All right, so 24, we've got 17 pi over 4, and if we divide here, 4 and 1/4 pi. So depending on you, if you're like a lot of people, you'll subtract off 2 pi and then subtract off 2 pi again. 2 pi, and I'm being a little bit loose here, and get pi over 4. The other possibility is to take 17 pi over 4 and multiply it by 180 over pi. And that'll give you some cancellation. I get some more cancellation here. 17 times 45, what's that, 405? 405. Subtract off your 360, you get 45 degrees, and that's pi over 4. So, again, I'm being a little bit loose here. This doesn't, this chain of events doesn't exactly equal all the way, but it's leading us to this reference angle. Cotangent of pi over 4. Are we okay with where we got to with pi over 4? One way or another, I'm hoping you're getting comfortable getting down to this. Cotangent is the cosine over the sine. And you might start getting familiar with the fact that at these 45-degree angles, at multiples of 45 degrees, the tangent and the cotangent are either 1 or negative 1. And in this case, it's going to be 1. All right. Any further thoughts on problem 24 or 26? Now I said, yes, please.
I was working on figuring something out, and I think I might have missed it, but could you just explain one more time how to rationalize like 1 over the square root of 3 over 2?
Sure. So 1 over square root of 3 over 2. Well, first things first, because we're dividing by a fraction, the rule is to multiply by the reciprocal. So I'll take 1, the numerator, times the reciprocal of this. The second thing is that we don't typically like rational numbers in the denominator. I think part of the reason for that is no longer something that we need to worry about, but textbooks are going to worry about it still. So if I multiply by root 3 over root 3, that's effectively multiplying by 1. So I'm not changing the value of this, but I am going to get something a little bit different. Square root of 9 is 3. And we've got rid of the rational, irrational part of the denominator and replace it with a nice rational number. So that's what we're looking for.
Okay, thank you.
Yes? Okay. Let's see here. You know what? This should have been 720. 765 minus. We'll do 720, which is 2 laps around the unit circle, right? All right. So thank you. And that leaves us with 45, which again is your pi over 4. Thank you. No, I appreciate you saying something. Thank you. Now, a little bit ago, I mentioned that the cotangent and the tangent of these angles that are multiples of 45 is either going to be 1 or negative 1. kind of depends on where you're at. So let's talk a little bit more about that. And to that end, let me draw myself a little set of coordinate axes. Let's think about the various functions and the points in each of these quadrants. Now the quadrants themselves are numbered using Roman numerals starting in the upper right, moving counterclockwise around to the lower right, so 1 through 4. And in the first quadrant, both x and y are greater than 0. So what's that mean in terms of your trigonometric functions that are based on those? Well, let's think about it. You've got your cosine of theta is going to be the x-coordinate. Sine of theta is going to be the y-coordinate. Tangent of theta is going to be the y-coordinate divided by the x-coordinate. And then you've got all the reciprocals. Cotangent is x over y. Cosecant is 1 over y. And secant is 1 over x. But in the first quadrant, since x and y are positive, all of those functions are going to be positive. What happens when we move over into the second quadrant? Which coordinate is negative, which coordinate is positive? In terms of x and y's. X is negative, so x is less than 0, y is greater than 0. So anything that depends on the y is going to be positive, if it just depends on y. So what function depends on y? Sine. And it's reciprocal, right? It's reciprocal to cosecant. So sine is going to be positive in the second quadrant, sine and cosecant. Let's move down to the third quadrant. In the third quadrant, x and y are both negative. But that leads to something interesting. When you divide a negative by a negative, what do you get? Positive. So what's going to be positive in the third quadrant? Good. Tangent. And it's reciprocal of the cotangent. So all of them are positive here. Sine and its reciprocal are positive here. Tangent and its reciprocal are positive here. Last but not least, in the fourth quadrant, x is greater than 0 and y is less than 0. Maybe you can complete my analysis here for me. What's going to be positive in the fourth quadrant? What big function? Cosine. And the secant. So it leads to a nice little acronym, a nice little mnemonic device for you guys. And that is, all students take calculus. Yay! See you next semester. Cool. All right, so all students take calculus. A little shameless self-promotion. Nothing wrong with that. Come on. All right, but it helps you out because we're going to start looking at angles and some information about trig functions and trying to figure out, well, where is this true? What quadrant could this be in? And it has implications for our work later on. So it's more than just kind of like a giggle ha-ha self-promotion. It does have some applications. And let's see that, starting with problem number 28. Problem 28, they ask you to identify the quadrant in which the sine of theta is less than 0 and the tangent of theta, no, pardon me, cosine of theta is greater than 0. Okay, Well, let me zoom out a little bit. Now, in each case, there's really a couple choices here. So, what choices do we have? Where could the sine of theta be less than 0? In what quadrant could this angle be? 3 or 4. And let's just leave that be for the second. All right, someone else here now. Where could the cosine of theta be greater than 0? Which quadrant's there? 1 or 4. Now, if both of these things have to be true at the same time, which quadrant is theta in? 4. Has to be quadrant 4. That's the only place where these two conditions overlap. Let me do another one like that. Problem number 32. Cosine of theta is less than 0, and the tangent of theta is greater than 0. Same kind of game with this one as opposed to the last one. So where could cosine of theta be less than 0? All right, good. Cosine of theta is going to be less than 0 in the second quadrant or the third quadrant, where x is less than 0. So 2 or 3. All right, someone else now. Tangent of theta. Tangent of theta is greater than 0 in 1 or in 3. So 1 or 3. Where do they overlap? 3. They overlap in quadrant 3. So that's where theta has to be. Let's try problem number 34. In fact, you try problem 34 and then check it with a neighbor. Your chance to be social. Cosecant of theta is greater than 0, and cosine of theta is less than 0. All right. Check it with a neighbor. Turn to your neighbor and compare answers. See how you did. It's your chance to interact with your fellow humans. Something other than Siri. All right. Sorry, droid. But you can still interact. Oh, you did? Who'd you talk to? You talked. Oh, you did a flyover. Okay, that's cool. Judy, chat with somebody.
Where's the cosine less than 0? Yes. So cosine less than 0. Fourth one and no. It's on 2 and 3. Yeah, 2 and 3.
Okay. So where can the cosecant be greater than 0? Which quadrants? Good, 1 and 2. All right, because it really relates to the y-coordinate, and the y-coordinate is positive in quadrants 1 and 2. The cosine is less than 0. Well, we don't have to think too hard on that one because we just did that. That's 2 or 3. Where do they overlap? 2. So theta is in the second quadrant. Yay. All right, are you getting comfortable with those types of things? As you move forward, this is just going to be one part of an even bigger problem. So make sure that you have this skill down pretty good. That's why I spend a little time, no kidding aside, but on this, all students take calculus stuff. It does come back at you. Now, I've mentioned it a lot of times, but let me actually write it down somewhat formally. There's some reciprocal identities. These are on page 130. So, reciprocal identities. The cosecant of theta is the reciprocal of the sine of theta. So it's 1 over the sine of theta. And of course, it works both ways. Sine of theta is the reciprocal of the cosecant of theta. Although we typically would never write that. Secant of theta. Which function is that the reciprocal of? Good. It's reciprocal of the cosine of theta. And then there's a couple more. Cotangent of theta is reciprocal of the tangent of theta. You could also think of cotangent of theta as, let's see, it would be cosine over sine. Cosine of theta over sine of theta. For good measure, let's throw in one last one, and that's the tangent of theta. Sine of theta over cosine of theta. So you're getting bombarded. But this is it. These are your basic trig identities, your reciprocal identities. And knowing your way back and forward across these is going to help you get a lot done. Let's try problem number 42. You know what? No, we're going to need to do a little bit more before we do 42. I need to introduce some more identities. So, yeah, more identities. We're going to work towards the Pythagorean identities. So, let's see here. Last time, I talked about all our trigonometric functions and derived everything based on the unit circle. What's the equation of the unit circle? Does anyone know? Has a center at 0, 0, and radius of 1. So that equation is x squared plus y squared equals 1. But let's fill that in with some trigonometric identities. What's the x-coordinate of your point on the unit circle? Anyone? What's the x-coordinate of your point called? Cosine of theta. So that's your x-coordinate, that's your y-coordinate. So this equivalently becomes cosine of theta squared plus sine of theta squared equals 1. Now this notation, I mean, it's fine, but it's not what we typically use. What we typically use for something like that is cosine squared of theta plus sine squared of theta equals 1. And that's your most basic Pythagorean identity. You're going to get a lot of work done from that one line. Cosine squared plus sine squared cosine squared of theta plus sine squared of theta equals 1. Let's just see an example of that. Well, let's pick one point from the unit circle and just check it. So, let's see. My unit circles disappeared. So one of the points at, say, a 30-degree angle has coordinates of square root of 3 over 2 and 1/2. Let's see if we put that in here, if that would work. So, for instance, square root of 3 over 2 squared, which is your cosine of 30 degrees, plus 1/2 squared, does that equal 1? What am I going to get when I square out this term? 3 over 4 plus 1 over 4, and lo and behold, that's equal to 1. All the points on your unit circle should satisfy the Pythagorean theorem. Now there's a couple other identities you can get once you have the Pythagorean theorem. So let's do those, and then we'll use those as needed. We'll try and use this for the most part, but we can use other ones as well. Cosine of theta squared plus sine squared of theta equals 1. Let me go back to the basic Pythagorean theorem. And what I'm going to do is I'm going to derive a couple different identities from this. Now, I've been teaching this class since 19 mumble, and I don't have all these different things memorized. When I need them, I derive them. You don't want to have to memorize a ton of different things. So here's what we're going to do. We're going to take this one identity that we know and divide everything through by cosine squared of theta. And let's see what we get in terms of some simplification. Now the first term, cosine squared over cosine squared, is 1. All right, so that's easy. What's sine over cosine going to equal? Tangent. So that's tangent squared. 1 over cosine squared is going to be secant squared. Cool. So we got another identity, essentially for free. Why don't you try the same thing? This time divide through by sine squared of theta. So cosine squared of theta plus sine squared of theta equals 1. Divide everything through by sine squared of theta, and then try and simplify it. Someone want to simplify this for me? Go ahead. Yeah. Oh, all right. Someone say, go ahead. Well done. Cotangent squared of theta plus cosecant squared of, or plus 1 equals cosecant squared of theta. Now in each of these, you could further play with the results to get even more identities if you wanted to, if you needed to. So in this one, for instance, if I moved the 1 to the right-hand side, I'd get cotangent squared of theta equals cosecant squared of theta minus 1. Over here, if I move the 1 to the other side, I get an identity for tangent squared of theta equals secant squared of theta minus 1. So you can get a lot of different identities, and like I said, I don't bother memorizing these things. The one thing you need to memorize is this trick of how to manipulate the Pythagorean theorem. Let's play with problem number 42 now. They tell us in problem 42 that the sine of theta is equal to 2 square roots of 2 over 3, and that the cosine of theta is equal to negative 1 over 3. First things first, can anyone tell me what quadrant we have to be in? So here you're either in quadrant 1 or 2. Here you're in 2 or 3. The difference between this one and the other ones we did is that you actually have numbers. That's okay. It's still telling you whether or not these functions are positive or negative. There's 6 trigonometric functions: sine, cosine, and tangent, and then the reciprocal functions. And I like to write them across from each other. So they'd be cosecant of theta, secant of theta, and cotangent of theta. They start us out with 2 of these. So let's put those here. 2 square roots of 2 over 3 and negative 1/3. Let's start with the easy one. What's the secant going to equal? Secant's just going to be the reciprocal of this, so negative 3. If you take the reciprocal of this, we'll get 3 over 2 square roots of 2, and we'll rationalize that. So multiply by root 2 over root 2. 3 square roots of 2 over, 4. So 2 down, 1 to go. What am I going to do to get tangent and cotangent? Tangent is sine over cosine of theta. So that's going to be 2 square roots of 2 over 3 divided by negative 1/3. You're fortunate in as much as the denominators are the same. So those denominators can cancel right away. You're left with minus 2 square roots of 2. Last but not least, I want to take the reciprocal of this to get this. Or I could calculate cosine over sine. It's going to be the same thing. Negative 1 over 2 square roots of 2. And I'll rationalize it. Negative square root of 2 over 4. So we started out with these 2 values, and we derived for ourselves the remaining trig values. So there's a total of 6 trigonometric values. They gave you 2, you had to figure out the remaining 4. Question? No? Okay. Now I'm going to give you one like this. The numbers are going to be a little bit friendlier. Not going to involve any radicals, but the idea is still going to be the same. So before I give you one, is there anything else about problem 42 that you'd like to discuss? Otherwise, I'll just let you work on problem number 36. Reciprocal of what, though? I mean, you gotta calculate one of them, and then once you get one, you're going to get the reciprocal of that to get the other. So, but at some point, you need to form a ratio of sine and cosine.
So what you solved for tan and got,
That's what we did. So once I solved for tan, I got this, and then I took its reciprocal, 1 over that. I just happened to put the negative out in front. But yeah, it's exactly what I did. I took the, so after that, then I rationalized it. Now I'm not sure exactly how picky I'm going to be about the rationalization. I mean, there's enough going on in this class that I'm not really worried about making you do a little bit of extra algebra. But in all honesty, you should be able to do this because that way you can check your answers in the back of the book. Yeah, that's probably a real good reason to be able to do it. I'm not really going to worry about it if you leave it like that. You know, if you get this, I'll be pretty happy. Okay. Anything else? Problem 36. Same kind of thing. Easier numbers. Again, we'll walk around and help out. This time, the sine of theta is 4/5. Cosine of theta is -3/5. So if you manage to get this one finished, then give yourself a little bonus problem of trying to figure out what quadrant this is in. What quadrant does the angle have to lie in? So sine of theta is 4/5. Cosine of theta is -3/5. What's the tangent of theta? What's the cosecant of theta? Secant of theta. And the cotangent of theta. So finish all four of those. It's just reciprocal of tan, so there. You could also do it as cosine over sine, but that's yeah. Yeah, so there's a couple different ways. Yeah, I'm just trying to. One's reciprocal of that, the other one is cosine over sine. I have a copy of it, but there's one online on the Desire to Learn site. Are you familiar with Desire to Learn? Just go to login to Desire to Learn, select our class, go to content. Yes. Syllabus is online. I list these in different orders so that when I take the physicals, I'm just going left to right. But it seems like you have to recommend line. Yeah, bonus problem. So for those of you who have solved it, go ahead and figure out what quadrant this is in. This divided by this is 9. And we take reciprocal Okay. The reciprocal of the sine of theta is the cosecant of theta. So the reciprocal of the sine is the cosecant. So the reciprocal of 4/5 is 5/4. Reciprocal of negative 3/5 is 5/3. And it doesn't change signs. It's still negative. When you take the reciprocal, it doesn't change signs. Tangent is your sine of theta over the cosine of theta. And if we take my values from up here, 4/5 divided by negative 3/5, again, we're fortunate in that as much as we have denominators that will cancel. That leaves us with negative 4/3. When we take its reciprocal, the negative is still going to stay there. It's going to become 3/4. So there's your 6 trigonometric values. This is exactly the kind of problem that I want you to be able to solve. Is there any misgivings about some of what we did here? Are all these? How many people got that one right? Yay! Good job. Well done.
You were saying something like this on the test. Is that why you?
Let me tell you in Spanish. Sí. Yeah, definitely. This is exactly the kind of problems I want you to be able to do. Now let's go a little further. Problem number 44. They tell you that the cosine of theta is 3/5, and they tell you that theta is in the 4th quadrant. Yes, sir. Oh, yeah, that's right. I asked you to go back and finish the quadrant. So this is either going to be quadrant 1 or 2. This is going to be quadrant 2 or 3. So winner, winner, chicken dinner, quadrant 2. Yay. Okay. Let's move down to this one. I'm going to write my same 6 trigonometric functions in that same order. Sine of theta, cosine of theta. Well, we know that one. That one's 3/5. And tangent of theta. And then the reciprocals. So you can go straight across and do the reciprocal. Cosecant of theta, secant of theta, and cotangent of theta. Houston, we have a problem. There we go. Now, of these, the only one we can calculate right now would be the secant of theta. Let's take care of that, the easy one, right? What's the secant of theta? 5/3. But if you want to get more than 1 point out of 5, then we're going to need to do a little bit more work. So let's figure out what the rest of these values are. To do that, I need something else here. How am I going to get that? Well, I know that sine squared of theta plus cosine squared of theta equals 1 is my famed Pythagorean theorem. So let's see if we can't make use of that. So sine squared of theta plus 3/5 in parentheses, then squared, that equals 1. Okay. Let's square out 3/5. When I square out 3/5, I get 9/25. And now I'm going to solve for the sine of theta. So let's move the 9/25 to the right-hand side. I'll get sine squared of theta equals 1 minus 25, or 9/25. But let's be careful about the way we write 1. How about if we write it as 25/25? So we get sine of theta, sine squared of theta is 16/25. But that's sine squared of theta. I want the sine of theta. All right, so yeah, you need to take the square root. So let's take the square root on both sides. Square root of sine squared of theta. Square root of 16/25. And if you're doing exactly what I'm doing, then you're going to miss a key point here. What am I missing here that I need? Well done. You need the plus or minus. So we get two possibilities. Sine of theta is positive 4 over 25 or negative 4 over 20, or excuse me, positive 4 over 5 or negative 4 over 5. Which one though? Why negative? Ah, well done. Here's where that stuff, all students take calculus, comes into play. Is we know that this has to be in the fourth quadrant. This is either in quadrant 1 or 4. And, well, that one says it's in 4. And sine of theta is negative in the fourth quadrant. So, negative 4/5. I'll pause for a second. You need to make sure that you get that negative sign there. If you use the positive 4/5, it's a couple points. Because it's a lot of work to get down to here and realize that we want the negative 4/5. Are we okay with that conclusion here? Thank you. The rest of it isn't too bad. The rest of it is kind of like our previous problem. So, what's the cosecant? Negative 5 over 4. The tangent, negative 4/3. And the cotangent is going to be negative 3/4. So, it's pretty similar once you figure out that. But that's a big extra step here. And you're using the Pythagorean theorem. Okay. Let's do one more like this. Problem 56. And we'll discuss some of the even-odd identities and be done with this section. Problem 56, I'm going to do cotangent of theta is 4/3, and the cosine of theta is less than 0. Let's figure out what quadrant this is in right now. Where could cotangent, or where could cosine of theta be less than 0? All right, good. 2 or 3. And the cotangent of theta equals 4/3, 1 or 3, right? Because it's positive. So overall, this angle has to be in the third quadrant. There's no other place that it can be in the third quadrant. I still need to find the values for my 6 trigonometric functions. So that would be, let's see, sine of theta, cosine of theta, tangent of theta, cosecant of theta, then what else? Secant of theta, and cotangent of theta. Well, we start out with cotangent of theta is 4/3. What's the other freebie that you get from this, essentially? Good. The tangent is 3/4. Cool. All right. Now, the rest of this is going to be a little bit more work. So, let's turn to one of our other trigonometric identities. We had sine squared of theta plus cosine squared of theta equals 1. But that doesn't help us out too much here because we don't know sine or cosine. We got another identity we got when we divided this through by, say, sine of theta, or by cosine of theta. We got tangent of theta squared plus 1 equals secant of theta squared. And that looks promising because we've got the tangent, right? Let's see if we can't make use of this right here. 3/4 squared plus 1 equals secant squared. What do I get when I square that out? 9/16 plus 1. But let's not write it as 1. Yeah. A couple voices for 16/16. I like that. 25/16 equals secant squared of theta. Yep. When we take the square root, we get the secant of theta is plus or minus 5/4. Which one do we pick? Minus, plus, minus, plus. Well, we're in the third quadrant, right? We determined that earlier. Is secant going to be positive or negative in the third quadrant? Negative. So I want secant here to be negative 5/4. Well, that's cool. That's helpful. Because that gives us another one pretty quickly, right? What else do we get from that pretty quickly? Cosine, good. So that's going to be negative 4/5. Two down, 2 to go. I still need to figure out what sine is. So, I don't know. Ideas from you guys. What can I do to figure out what the sine is? Could. Sri? Go ahead. You mean this one up here? Yeah, perfect. Let's go back to the original Pythagorean theorem. We know what cosine is. So sine squared of theta plus negative 4/5 squared equals 1. When I square that out, I get 16/25 equals 1. Move that to the other side. I'll write 1 as 25/25. And when I subtract, I get 9/25. When you take the square root of both sides, sine of theta is plus or minus what? 3/5. Yeah. Yeah, there's a lot of different ways you could do this. Sure. We also had an identity involving the cosecant and the cotangent. Might have been able to work something out with that one as well. But yeah, there's a lot of different ways you could work this. Now, which one do I want? Do I want the positive or do I want the negative? Negative, because you're in the third quadrant. So it's going to be negative 3/5. And that finishes off here with negative 5/3. Whew. All right. Don't worry. I'll only put like 8 or 12 of these on an exam. Yes? Well, yeah, but the question would be what that denominator is. I mean, you can't. I mean, tangent is 3/4. I mean, is the denominator 12? Is it 5? Is it square root of 3? I was going to have the same denominator? Yeah, I think it is. I hesitate saying that without really thinking it through. There's always these weird exceptions, but yeah, I think it would be the same denominators. Yeah. No. I was really messing with you. No, I mean, there's two things. One, you wouldn't want to do it. Two, I wouldn't want to grade it. So no, it's not going to be. There will be one, probably like this. What I do when I write the exams, I'm not adventurous. Look, I've got other things to do in my life, football games to go to, etc. I look through at the book. I'm like, oh, we did one like this, and I put that one in there. Oh, there's another section of problems. Oh, we did one from this section, and that's how I write your test. So it's pretty straightforward. And these problems are coming directly from the book, directly from your homework. So if you're doing this stuff, you're seeing your exam. So I really encourage you to do the homework and keep up with things. And we're posting these videos online to help you out as well, in case at some point things go too fast and you're a little too shy to say, hey, wait a minute, I don't understand. I hope that's not the case, but I know my experience as a student, I hated to ask questions. That changed when I got to graduate school. At that point, I knew that if I didn't ask a question, nobody would, and I got tired of not knowing what was going on. So, I mean, do yourself and me a favor. If you don't understand something, please ask a question. Last little section to cover, and that's our even-odd identities. Even-odd identities. And I want to get you on a break and finish this up at the same time. So these are on page 132 if you want to look at things there. Actually, you know what? Page 135, my bad. Page 135. And you know, I'll show you one or two maybe, and then the rest I'll just kind of give you. All right, so here's our unit circle. And let's put a theta, an angle theta in here. Like this. So here's some angle theta. Now that angle theta is going to intersect the first quadrant at some point, x and y, like that. What if instead of moving an angle theta, I moved a negative angle theta, minus theta? What would the coordinates of this point be? You should be able to tell me, based on that one, what the coordinates of that point will be. X and negative y. All right, perfect. X and negative y. Let's look at the implications for a couple of these trigonometric functions. If I was to take a look at the cosine of theta, the cosine of theta is x. What's the cosine of negative theta going to equal? So basically, the cosine of theta equals the cosine of negative theta. It doesn't matter if you're taking the cosine of a positive angle or a negative angle. You're going to get the same thing. You can verify that on your calculator. So I'm going to put my calculator in degrees for just a moment. So mode, let's put it in degrees. You know, it is easier to think in degrees. So if I do the cosine of 30 degrees, I get the decimal equivalent of square root of 3 over 2. If I do the cosine of negative 30 degrees, I get the exact same thing. So cosine is what's called an even function. When you look at its graph, do you know the property of evenness? What's the graph of an even function look like? Think of a parabola. How's a parabola look relative to the y-axis? Right? And relative to the y-axis, it's symmetric. So let's just do y equals cosine of x. And it helps if I turn that on. There you go. You've got a nice symmetric graph. So it starts out at 0, then it decreases, and then it increases, etc. But it's symmetric. Also, based on the graph, you can see that the function repeats itself every now and then. If you move a distance of 2 pi to the right, the wave starts itself all over again. Or 2 pi to the left. Same thing there. So there's some special points along the way. Let's take a look at the sine function. What's the sine of theta? That's going to be y. What's the sine of negative theta? negative y. So the sine of theta can be thought of as the opposite of the sine of theta. It's as if that negative factors out. It's not exactly perhaps the right way to think of it, but that negative can be brought out. So this is another one of your even-odd properties. That makes sine what's called an odd function. Sine of negative theta equals a negative sine of theta. Cosine of negative theta equals a cosine of theta. For cosine, that negative vanishes. For sine, it doesn't.
So basically we just take the sine and then multiply it by negative and that's it.
Yeah. So if I wanted, for instance, to calculate the sine of negative 30 degrees, I can say, well, that's the negative of the sine of 30 degrees, which would be negative 1/2. Done. It's nice to be able to get rid of the negatives that way. Once you've demonstrated those, the tangent of negative theta can be thought of based on the definitions. That's the sine of negative theta over the cosine of negative theta. Or negative sine of theta over cosine of theta, which is negative tangent of theta. So you've got all these types of identities, and basically they follow from knowing those first two. So if you know these two here, you can derive whatever else you need. So the next one is tangent of negative theta equals negative tangent of theta. Now there's a total of 6 of them. Please take a look at page 135 for those. We'll just do maybe 1 or 2 more examples and we'll be done with this section. Problem number 60. Cosine of negative 30 degrees. Well, that's a friendly one. Does the negative sign really make a difference to the cosine function? No. So we can just think of this as the cosine of 30 degrees. And the x-coordinate there is root 3 over 2. Beautiful. And problem number 70. Sine of negative pi over 3. Here the negative comes out in front. It's sine negative of the sine of pi over 3. So it's going to be negative. Now you need to look at your unit circle. Sine is which coordinate on the unit circle? Sine is the y-coordinate, so the y-coordinate of pi over 3 is root 3 over 2. Done. For homework, this is section 2.3. Homework for this section starts on page 136. Try problems number 5, 11 through 23, 27 through 51, 59 through 73, 77 through 85, and 89. It may sound like a lot, but I'll give you a week to work on it, okay? All right. Let's take a break here. I'll see you in 10 minutes.